We could use logarithm functions to solve this problem with an initial condition, but I'm going to look for a more direct approach. We're given that 5 raised to the x plus 2 is equal to 11. And again, you use logs to directly find x and then just substitute over here. But there's a way to do this just based on laws of exponents, which isn't surprising. So let's take a look at that approach. Now, it's pretty clear you should rewrite what we're trying to evaluate in this form. It's just easier to work with it, probably. At least I think so. So we have the object we're trying to evaluate written in this form, and rewriting our given in a fractional form motivates the following approach here. You can just take 5, and again, this is just a rewrite of our given, okay? But 5 raised to the x plus 6 over 3, okay? Now, what are we looking for? We're looking for 5 to the x plus 10 over 3. So it certainly follows that we should just multiply by 5 to the 4/3, whereby when we add exponents, we get what we want. So if we're going to multiply by 5 to the 4/3 on the left-hand side of this, we need to do the very same thing on the right-hand side. So we get 11 times 5 raised to the 4/3 power. And again, y'all, the motivation on that is, or the property that we use is just that a to the m times a to the n is equal to a to the m plus n. You just sum up the exponents. You see that's exactly what happened right here. You multiplied this. You multiplied this times this, and we're going to actually add. I haven't done it yet, actually, so let's write that down. So when you add these exponents, think of this whole thing as your m and this whole thing as your n. You would get 5 and again add 4/3 to x plus 6/3, like terms, gives you 10/3. Okay, but that is what we're trying to find, right? Okay, so that's equal to 11. Now, it's useful to rewrite this as 11 times 5, and I'll put to the 1 here for emphasis, times 5 to the 1/3, right? Now, again, the 1 that you see right here is superfluous. It's unnecessary, but it's instructive to write it that way. So what we'll get right here is 5 times 11 is 55. And you can write this using radical notation. 5 to the 1/3 is the very same thing as the cube root of 5, which is our answer. 55 times the cube root of 5. Okay, y'all, no logarithms required for this problem, just direct manipulation. Or we're just appealing to the laws of exponents, essentially, is what motivated all the steps. Anyway, that is the solution, 55 times the cube root of 5. Okay, so right here we get, this is equal to 55 times the cube root of 5. Okay, good night.